Earlier we have finished, I have solved two problems of the how to calculate bearing capacity of strip footing, given value for sand stratum and phi is 32 degree, it is in between local shear failure as well as general shear failure. Second one, I have also solved one example considering water table effect at a depth 0.5 meter below the ground surface and at a depth 0.5 meter below the base of the footing. Now, besides the Terjagi's bearing capacities theory, there are also other theories available. So, Skempton has given bearing capacity analysis for clay soils. Applicable for saturated clay, these are his empirical relations Skempton has given, and for strip footing NC is equal to 5 into 1 plus 0.2 df by b with maximum .5. Then second is your square and rectangular footing NC is equal to 6 into 1 plus 0.2 df by b with a maximum .0. For rectangular footing, NC is equal to 5.0, 1 plus 0.2 df by b into 1 plus 0.2 b by L, then here it is 7.5 into 1 plus 0.2 b by L. Here it is for df by b less than equal to 2.5, for df by b greater than 2.5. So, sorry, it is not square and rectangular, rather it is square and circular footing. So, he has given for three conditions, particularly clay soils. Strip footing NC is equal to 5 into 1 plus 0.2 df by b, maximum is your 7.5. Second is your square and circular footing, NC is equal to 6 into 1 plus 0.2 df by b, maximum is your 9.0, here it is your 7.5. Rectangular footing, NC is equal to 5.0 into 1 plus 0.2 df by b into 1 plus 0.2 b by L for df by b less than equal to 2.5, and which is equal to again for rectangular footing df by b greater than 2.5, it is 7.5 into 1 plus 0.2 b by L. So, this is what this Skempton has given for your saturated clay. Initially it has been given by Terjagis, now it has been modified again basic. It is called basic bearing capacity theory or bearing capacity factors. If you look at what is the difference in Terzaghi and basic, if I draw it Terzaghi and basic, then basic free body diagram of the Terzaghi, then you will be understanding what is the difference of this. In Terzaghi, what Terzaghi has given, generally I allow these charts in examinations, no need to remember or memorize this chart. So, particularly Terzaghi, if you look at here, this is your gamma df and this is B and this is A, B, D, this is zone 1, this is your zone 2 and this is your zone 3. So, Terzaghi bearing capacity assumption of the zone 1 and zone 2 and zone 3. Zone 1 is your elastic zone, zone 2 is your radial shear zone, zone 3 is your Rankine's passive zone, and this will be 45 degree minus pi by 2. If I come to the zone 1 in Terzaghi's, so in zone 1 if you look at here, this is your width B and this is your QU and this is your phi, this is your phi, then here it is CA, then there is a PP, both the sides. That is what I have explained earlier Terzaghi's bearing capacity theory. Now you come back to basic, this is your Terzaghi, this too is your Terzaghi. Now come to the basic, what basic assumption is, so inclined surface, particularly if I look at inclined surface, what is your inclined surface? AD and BD makes horizontal with your phi angle. Here they are saying that this angle supposed to be 45 degree plus phi by 2. This is the only change as compared to Terzaghi's. Basic what happened? In zone 1 is your elastic zone, zone 2 is your radial shear zone, zone 3 is your Rankine's passive zone. This is as per your Terzaghi's. So, in zone 1 as per the Terzaghi's, the angle of this particularly inclined surface AD and BD, they makes an angle phi, but basic said it makes an angle with 45 degree plus pi by 2 instead of phi. Now based on that he modified NC is comes out to be NQ minus 1 into cot phi, then NQ is equal to e to the power pi tan phi into tan square 45 degree plus phi by 2, and N gamma is equal to 2 into NQ plus 1 into tan phi. So, if you look at here, they have also given charts in terms of value phi and N gamma 0, 5 degree, 10, 15, so on up to your 50 degree. So, 0, 0, here it is 0.4, here it is 1.2, here it is your 2.6. So, instead of making phi with your inclined failure surface, it makes an angle 45 degree plus phi by 2 in case of your Terzaghi's. After Terzaghi's, what happened? After Terzaghi's, the value has been given by Meyerhof. What are the implementation of for your Meyerhofs? So, it is called Meyerhof 1951. Meyerhof 1951 gave comprehensive analysis of bearing capacity of strip footing at any depth. Meyerhof 1951, he has modified particularly Terzaghi's case. What he has given the general bearing capacity theory, if you look at here, Qu is equal to CNC FCS FCD plus FCI plus QNQ FQS FQD FQI plus 0.5 gamma B N gamma F gamma S F gamma D F gamma I. If you look at these terms in terms of Terzaghi, what is this Qu? Here it is only CNC plus QNQ plus 0.5 gamma B N gamma. So, what he has introduced, if you look at here, FCS, FQS, F gamma S, it is your shape factor. Then FCD, FQD, F gamma D, this is your depth factor. Then FCI, FQI, F gamma I, it is your load inclination factor, and NC, NQ, N gamma are your Meyerhof's bearing capacity factors. So, if you go back to Terzaghi's, what they have given, only 3 shapes. Initially it is a strip, it has been modified to square, then rectangular or circular, then depth is, it has been made up to a shallow depth. In this case, at any depth they say bearing capacity depth factor, then load inclination. In case of Terzaghi, it is only vertical, no inclined load. So, he has taken all the assumptions, whatever, all the limitations in the Terzaghi's bearing capacity theory, it has been taken care, means it has been taken into considerations and put it as a Meyerhof's bearing capacity theory. Then if I draw it, earlier Terzaghi's bearing capacity theory with a, there is a footing here, and this is your base of the footing, this is what your this, then there is a wedge, then if you look at here, here it is your 45 degree minus phi by 2, here it is 45 degree minus phi by 2, then here A, C, D, this angle is your alpha, alpha is equal to, for Terzaghi's bearing capacity theory it is phi, for basic bearing capacity theory it is 45 degree plus phi by 2. Now, if you look at here, particularly in case of Terzaghi, what he says, alpha is closer to 45 degree plus phi by 2 than phi. It is in between. Terzaghi alpha is equal to phi, basic alpha is equal to 45 degree plus phi by 2, and in case of Meyerhoff's general bearing capacity theory, he has included 3 factors: any shape of the foundation, any depth factor and load inclinations. It should not be vertical, it should be any load inclination, and alpha, particularly this angle in case of your elastic zone, if it is zone 1, zone 2 and it is zone 3, it is closer to 45 degree plus phi by 2 than your phi. It is neither phi nor 45 degree plus phi by 2, rather it is closer to 45 degree plus phi by 2. Then your NQ is coming about to be tan square 45 degree plus phi by 2 and e to the power pi tan phi, and C is equal to NQ minus 1 into cot phi, and n gamma is equal to 2 into NQ plus 1 into tan phi. He has solved it. The free body diagram and solutions, it will be kind of in advanced foundation engineering, not in foundation design, particularly in BTech level. You should know the basics and how it has been come up and what are the basic difference between your Terzaghi's basic and Meyerhoff's theories. Details are there, detailed derivation is there. If time permits, I will show you the free body diagrams and how the forces are coming and how it has been solved, so that you can have an idea about what is the difference between Terzaghi, basic as well as in case of Meyerhoff's. So, if you look at here, there are different relationship based on your Meyerhoff's theory, different relationship has been given. This is your factor, this is your relationship, and the who are the authors. You can collect this information from the books. If I write bit by bit, it will be time consuming. Now, if you look at here, for example, this is shape, this is depth, first one is your shape, this is your depth and this is your inclination. Now, if you look at this shape, FCS is equal to 1 plus B by L NQ by NC, FQS is equal to 1 plus B by L tan phi, F gamma S is equal to 1 minus 0.4 B by L, and this has been given by Hassan. (1970). Then depth factor again it has been given by Hansen 1970. So, there are two conditions. In one conditions, if dF by B is less than 1, so then FCD is equal to 1 plus 0.4 dF by B, FQD is equal to 1 plus 2 tan phi 1 minus sin phi whole square dF by B, and if gamma D is equal to 1. Condition 2, if df by b is greater than 1, in that case FCD is equal to 1 plus 0.4 tan inverse df by b, then f qd is equal to 1 plus 2 tan phi 1 minus sin phi whole square tan inverse df by b, f gamma d is equal to 1. Then for inclinations, it has been given by Mayer of 1963. So, what they have given, FCI inclination is equal to FQI, which is equal to I minus beta 0 degree minus 90. Then F gamma I is equal to 1 minus beta by phi into whole square. Beta is your inclination of the load on the foundation, inclination of load. Suppose this is my load, suppose this is my footing, then this is the case, and this here I can put it inclinations. So, this is what your Meroff has been given, Hansen has been given, and this shape, depth and inclination factor, it can be utilized in case of Meroff's theory, and then you can put it, and the bearing capacity can get it any shape, any depth, any load inclination of your foundations. Now, there is one term called scale effect. What are the scale effect on bearing capacity? Before I further proceeds, there is also IS code provisions, Bureau of Indian Standard provisions, also from the field test like SPT, we can find it out what are the bearing capacities. So, scale effect, next come to your scale effect. Scale effect particularly on your bearing capacity. Ultimate bearing capacity decreases, number 1, first one. Ultimate bearing capacity decreases with increase in size of the footing. It is more in case of more in granular soil, that means the decrease is more in granular soil. Then second part is your decrease in N gamma with foundation width B, and it remains almost constant for a large value of B. Now, what are the cause, why it is happening? If you look at here, before I am writing this cause, if you look at your ultimate bearing capacity Qu is equal to CNC plus gamma df NQ plus 0.5 gamma B N gamma. This is your surcharge, this is your wedge at the base of your footing. That means, what does it mean? If everything is constant, same soil, if you look at this equation, everything is constant, same soil. As I increase the B, width of the foundation B, what will happen? that means my bearing capacity is increasing. It is not true. Look at here, decrease in n gamma with width b, that means with width b means with increase in width b. It does not mean that suppose there is a 2 meter size of the footing, here it is a 2 meter, here it is a 5 meter, here it is a 10 meter. It does not mean that if I increase the size of the foundations to 5 and 10 or 20 meter, my bearing capacity will increase. It will be kind of for a large value of B, it is kind of it will increase, decrease, or you can say that it remains constant. For large value of B, large value of the B, whatever you increase beyond this width of the foundations, the bearing capacity remains constant. So, why this is happening? This is called your scale effect. So, what is the cause? The cause, first one is for large size foundation, the rupture along the slip lines in soil is progressive, and the average, look at here, average shear strength mobilized along a slip line decreases with increase B. So, second part is your, there are zone of, I can say, weakness which exists in the soil under the foundation. The curvature of Mohr-Coulomb envelope, another part is the curvature of Mohr-Coulomb envelope. If I take a Mohr-Coulomb here, Mohr circle, the failure envelope should be, it should be a curve. But in shear strength what happened? It has been assumed and approximately it has been put as a straight line, straight line. So, because of this curvature of your Mohr-Coulomb failure envelope, that may be one of the reason. Large size foundation, look at this, these three are very vital, you should understand. Large size foundation, the rupture along the slip lines in soil. What is your slip line for Terzaghi? Inclined face is progressive, and the average shear strength mobilized along a slip line, average, look at here, the average shear strength mobilized along a slip line decreases with increase in B. It is not necessarily that average shear strength will increase as we are going to increase the B. There are zone of weakness also below the foundations, but most important part, the curvature of your Mohr-Coulomb. The Mohr-Coulomb is a curvature, because of it is a curved. So, this kind of, so it is certain part it will increase, then it is not going to be increased, rather it will be decreasing. So, this is what is your scale effect. That means as I go on increasing size of the fitting, it does not mean that my bearing capacity will increase. the bearing capacity of the foundations up to a certain value of B will increase, then thereafter either will decrease or it remains constant. Even if I increase the bearing capacity, even if I increase the size of my footing size, suppose I increase from size of the footing from 2 meter to 5 meter, expected bearing capacity will increase. From 5 meter to 10 meter, I expect also bearing capacity to increase, but it does not mean that if I increase from 10 meter to 15 or 20 meter, the size will be going to increase. So, it will be remain constant. The size after a certain size, the width B after a certain size, it has no impact on the bearing capacity factor. This is called your scale effect. Why this has been explained latter phase, as soon as this bearing capacity theory and settlement is over, then we will go slowly one by one design of the strip footing in sand as well as in clay, design of your mat foundations. There you have to play with your size of the footings. Beyond certain size, it has no impact on your bearing capacity of your footings. So, I will stop it. So, next class I am going to start, few of them are remaining as per your Bureau of Indian standard, what is your bearing capacity, and from the field study particularly SPT and CPT, whether you can get directly your bearing capacity of your soil. Thank you.